Okay, today is May the 4th. May the 4th be with you and also with you. We have 4 questions here, all from section 9.3 of our MathLinks textbook on solving linear equations in more than one step. The first question we have gives us negative 2x minus 4 is greater than or equal to negative 5, and it asks us simply to graph the solution. In order for us to graph that, we have to isolate for x. Otherwise, we don't know where our boundary points are. So in order to isolate, we follow all of the steps we would do with our equalities or our linear relations. Once we get to here, though, remember what we said before. If you multiply or divide by a negative value in your process of isolating the value, isolating the variable, in this case dividing by negative 2, you have to flip the inequality sign to make sure it's right. So our solution is x is any number that's less than or equal to a half. Since it's asking us to graph the solution, I'm going to put a half in the middle. I'm going to put 0 down here. I'm going to put 1 over here. We'll be using open or closed boundary point. Closed. At any number less than or equal to means my number line goes that way to infinity. And somebody asked, could it also be this? You could also have x is less than or equal to a half. Totally okay to have it as a fraction. They're both the same number. Our next question gives us a negative half of x minus 3 is less than 4. Again, isolate the variable through the process you've learned since grade 7. Multiply by negative 2. Remember, when you multiply by a negative value, you have to flip your inequality sign. So our solution is any number that's greater than negative 14. Our set will use this bracket, that fancy looking bracket there, and any number greater than negative 14. So what's the first integer I'm likely going to write? Negative 13, negative 12, negative 11. And that is your set of valid numbers to infinity that would be inserted into here to make sure it's true. Now let's just double check. So on your test, you might be asked to verify your solution as being correct. In this case, you could take more than one number to verify. I always like to take the middle number in my set just to see if it's right. Insert that where, oh, that's not a marker. Insert that where my x is. So instead of x divided by negative 2, I put negative 12 divided by negative 2 minus 3. This works out to be 6. 6 minus 3 is 3. And therefore 3 is less than 4 and is a valid number. Our next question, negative 3 groups of negative 2x plus 1 is greater than or equal to 12. 2 ways you can solve it. And in fact, I'm going to do it real quick both ways. I'll clone it. Just to remind those people who, why won't it clone? Why won't you clone? Jack's not here today. And clone. And bring it over here. So obviously, how many of you did this? How many of you did this? Okay. Either way works. If you expanded it, you got 6x minus 3 is greater than or equal to 12. You added 3 to both sides, you get 6x is greater than or equal to 15. You divided both sides by 6, and you got x is greater than or equal to, what would that be? 2.5, right? 2.5. If you divided both sides by negative 3, what do you have to do right now? You have to flip your sign, don't you? Right? Because you divided both sides by negative 3. And then you subtract 1 from both sides, you get negative 2x is less than or equal to negative 5. And then you divide it by negative 2 again, which means you have to flip your sign again. But either way, you ended up with the same answer, depending on if you expanded using distributive property or if you divided both sides by negative 3. And if we graph our solution, I'll just pull this down just a little bit. Any number greater than or equal to 2.5 means 2.5 is in our middle. Likely 2's there, likely 3's here. Closed boundary point, any number greater than or equal to 3 is our solution. And our last question gives us variables on both sides. In order to isolate, probably most of you did what? Added x to both sides, correct? You could also have subtracted 3x from both sides. You could have also subtracted 1 from both sides. You could also added 4 to both sides. You could have actually put a pineapple on both sides. It doesn't matter, because in algebra, whether it be an equality or an inequality. As long as you do the same thing to both sides, it maintains the equality. I'm going to add x to both sides. Leave me with 1 is greater than or equal to 4x minus 4. I'm going to add 4 to both sides. 4x is less than or equal to 5. Divide both sides by 4. And our solution is x is less than or equal to 1.25. Okay. Now if we create our set of numbers, all numbers less than or equal to 1.25 means that 1.25 is my first one. What do you think my next number is, even though there's infinite numbers? It is 1. And what do you think the number after that is? No, 0.75 with a dot, dot, dot. Why did I choose those three? Because the scale or the progression of it's each going down by decimal 0.25 is consistent. You don't have to. You can do whatever you want. But those would be the best 3 numbers to use. Oh, I did forget to verify, didn't I? So let me just pull this down here. Of the 3 numbers, I'm going to choose to verify my solution with the middle one again, 1. So negative 1 plus 1, I guess, change x to 1, is 0. Change x to 1, I get negative 1. Is 0 greater than or equal to negative 1? Yes, it's greater than negative 1.